Okay, this is page 7 of the communication notes, and the second arrival rate or service rate type that we're going to discuss is Markov, so it gets the initial M, and Markov was a Russian mathematician that looked at random processes and variables and stuff like that. So Markov process, it's a sequence of random variables, and the key thing about it is that it's memoryless. So that means that the value of the next variable or value that's produced is independent of the values that have been produced before. So it is two things: stochastic, which means, let's do this in green, a sequence of random values, and it is memoryless. So for our purposes, the time between each arrival, the in-arrival time or service, so basically the service time, is independent of the previous time. So if we go back to clients waiting or queuing up at an ATM, the length of time that the next client is going to take using the ATM, so being serviced, is independent, or doesn't have anything to do with how long it took the previous one, or that's the assumption at least. Okay, in Lab 4 you're going to simulate a client-server system or a queuing system, and you'll use an equation to do that. That's developed in the textbook if you want to look at it in section 15.2. Douglas actually has a master's in mathematics, so he's pretty good at that stuff, and you can learn about how that simulation works, but we're not going to bother with it here. We're more interested in actually using the queuing theory to make predictions about our system. So queuing systems are described with Kendall notation. So this is Kendall notation for queuing models. I kind of hesitated when I was writing the title for this section on the previous page, right at the start there. I wasn't sure if there was an extra E before the I there, and I was just looking online, and one of the major, I guess, publications in this area includes the E. Seems to be the preferred spelling, and apparently it's the only English word with more than 4 consecutive vowels. So a bit of interesting trivia there. So the notation is like this. It's got 4 parts. So A is the arrival model. And that is going to be either D or M. We're going to be looking primarily at Markov arrivals and Markov service times. And then S is the service model. Didn't quite leave enough room there. And that also can be deterministic or Markovian. And C is the number of servers. And we are only going to be looking at 1 for this course, but it can be other numbers. There have been equations developed for multiple servers. And then k is the queue length. So if you don't specify a queue length, then it's assumed to be an infinite length queue. When we get to modeling bounded buffers, then we need to use a specific queue length, and we'll get to that.